Hello viewers, welcome to Lessons with Philip. And today our topic is on geometric progression. And here on the board we have a question, okay? Now, before I solve this question which is on the board, let me briefly explain what we mean by geometric progression. And don't forget, in our previous classes, we have done some examples and we've explained on arithmetic progression, okay? Now, geometric progression is a sequence in which their terms differs by a common ratio or by a common factor. Okay, when you see the term of a sequence having a common ratio or a common factor, that kind of sequence is known as geometric progression. Let me give some examples so that you understand the differences. Okay, now let me give an illustration between arithmetic progression and geometric progression. Okay, now for example, when we're dealing with arithmetic progression, if I have this example 2, 4, 6, 8, 10, and so on and so forth. Okay, this sequence is an arithmetic progression because the first term differs from the second term by an addition of 2. Okay, the second term differs from the third term by an addition of 2. That shows their differences is common, but the difference is it is an addition of 2. Okay, now if I have this sequence 16, 14, 12, 10, and so on and so forth. I can still use this example. Now, this sequence, somebody is saying, why am I using differences of 2? Okay, I will use another example. If I have, let's say I have 9, I have 6, I have 3, I have 0. This is another sequence. If you check this, it is also the differences is 3. You see, 9, I'm subtracting 3 from this. Now, 9, I subtracted 3 from 9 to give me 6. I subtracted 3 from 6 to give me 3. Subtracted 3 from 3 to give me 0. Now, the next one will be what? Minus 3. The next one will be what? Minus 6. These two example is an AP because the difference is either a common difference, which is an addition or a subtraction. But for a GP, it is a constant factor, which is also known as a common ratio. So when you say a ratio, that shows it's a fraction. Okay. Now, for a GP, let me give an example. If I have 64 and I have 32, I have 16, I have 8, and so on and so forth. This sequence is a GP. Somebody say, how do I know? Okay, I'll prove it now. 32 divided by 64 will give me what? Half. Okay, 16 divided by 32 will also give me half. 16 here 1, 16 here 2. Okay, 8 divided by 16 will also give me 2, half. Okay, you see I'm having a common ratio. So this sequence is GP. Somebody say, why didn't I subtract? Okay, let's subtract. 32 minus 64 will give me 32, minus 32 rather. Okay, 16 minus 32 will give me what? Minus 16. Okay, 8 minus 16 will give me what? Minus 8. You see? Are they common difference? They are not. Automatically, they are what? It is a GP. That is how to clarify when a sequence is a GP or an arithmetic progression. Okay? So don't forget, a GP is a sequence of a term in which the differ, either the decrease or the increase, with a common factor or a common ratio. Okay? All right. Let's solve this example. Solution. Okay. We are told that the third term of a GP is 360. Okay, now that shows that what I'm giving in this question, let me write what I'm giving. The third term, before I solve this question, there's another thing I've forgotten to explain about GP. I just remember just now. When we're explaining arithmetic progression, you can go to our previous classes. We explained that the nth term of an AP is given, the nth term of AP is given to be first term plus open bracket n minus 1 multiplied by common difference. This is for the nth term. Automatically, if you have to find the value of a particular term of an AP, you use this formula. Same way, geometric progression also have its own formula. Okay, now the nth term of GP is given as a r raised to power n minus 1. First term multiplied by r, a common ratio raised to power n minus 1, where a is what? First term. A is first term. Okay, don't forget, r is what? Common ratio. Okay, and n, don't forget, I've always been telling us that n in sequences is known as number of terms. Okay, if you have gotten this right, then we can proceed to our question. Okay, now the question on the board is very simple, very simple. Okay, let me write solution. Okay, now let me write the parameters that have been given in the question. Okay, I was told that the third term of a GP is 360. Automatically, the third term of my GP is 360. What is? And the system of the GP, is 1215. What else am I giving? Nothing. I'm asked to find the common ratio and I'm asked to find the first term. If you check the nth term of a GP, for you to find any term of a GP, you must know the first term. You have three things to know: the first term, the common ratio, and the number of terms. In all this question, we are not given the first term, we are not given the common ratio. We have to find them. Okay, now we'll continue, we'll start from there. Now, okay, let me start from this. Okay, when my third term is equals to 360, automatically then my n will be equals to what? 3. Okay, don't forget this third term. We always write the formula like this: u subscript n. So that shows that we have cleaned this n and we have put 3. That shows the n that was here, the n that was here is what? 3. Okay, now I cannot substitute. If I substitute n equals to 3 in AR n minus 1, automatically I have what? The n term of the GP is now 360, and my AR, I have AR, my n is what? My n is now 3. That will be 3 minus 1, And 3 minus 1 is what? 2. That shows that my 360 is equivalent to AR raised to power 2. Equation 1. It's very simple. We're getting there. Now let's go to this second thing that has been given. Okay, when sixth term is given to be 1215, then my n is equals to 6. So I can get an equation from this. If I want to get an equation from this, that shows that my sixth term, which is equals to 1215, which should have been equals to AR n minus 1, but the n is now 6, so I have 6 minus 1. So my 1215 is equivalent to AR raised to power 5. Okay? Don't forget this AR is not a singular thing. It is A times A multiplied by R raised to power 5. Please don't forget. Don't make that mistake. Okay? Now, this will be my equation 2. Okay? Now, the only thing I can do is to solve equation 1 and equation 2 by dividing either equation 1 by 2 or equation 2 by 1. We'll get the same thing anyhow. Okay, I can say divide equation 2 by equation 1. Okay, what is equation 2? Equation 2 is 1215 equals to AR raised to power 5. And I'm asked to divide this equation 2 by equation 1. What is equation 1? Equation 1 is 360. That shows I divide this by 360. Divide this one by 360. I divide this one by AR raised to power 2. Okay, something is common here. Okay, that shows that this A is common to both sides, so it can go away. Okay, now I think something can go in this. Okay, 45 can go in this. 45 in 1215 will give me 27. And 45 in 360 will give me 8. Now I'm left with R raised to power 5 divided by R squared. Okay? Now, this is now an indices. Now, we have discussed solving indices in our previous classes. Now, previous videos, you can just check our previous videos. Now, this one, if I tell you that this one is also equivalent to R raised to power 3, how do I get this? Now, I can change this. R raised to power 5 divided by R raised to power 2. Okay? This is equivalent to R raised to power 5 minus 2. There's a law of indices that says that when we have A raised to power X divided by A raised to power Y, as long as it's the same index form, it can be the same. You just subtract their power. That is A raised to power X minus Y. And that's why I've written it like this. What you just need to do is, this is a division. You just subtract. You see this sign. You just subtract the power. Okay? But when it is a multiplication, if it is R raised to power 5 multiplied by R raised to power 2, what you just need to do is you add the power since they are the same base. What you just need to do is R raised to power 5 plus 2. You see, this is just an inverted plus. You just add their power and to give you this. Okay? Now, you can check our previous classes. We have dealt with indices. Solemnly, we have dealt with indices. And we have said when we have A raised to power X raised to power Y, this is the same thing as A raised to power X times Y, because if you remove this bracket, what you have here is multiplication. Okay? Now, take note, please. Okay? If I apply another law of indices to this, this is the same thing as 3 raised to power 3 divided by 2 raised to power 3. Okay, 2 raised to power 3. 2 in 3 places will give me 8. 3 in 3 places, 3 times 3, 9. 9 times 3 will give me 27. And this is now R raised to power 3. Okay, now they both have the same power. So automatically 3 divided by 2 raised to power 3 will give me R raised to power 3, because they both have the same power. And that's what I just explained now. When we have, it's just like when we have square root of X over Y. This is the same thing. This square root applies to both. This is the same thing as square root of X divided by square root of Y. Okay? Now, when we have X over Y raised to power 2, this is the same thing as X raised to power 2 divided by Y raised to power 2. Okay? The power will affect both the numerator and the denominator. And that's what I've done. Because they have the same power, I can bring them on the same power. Okay, I can return this to this if I want to. So 3 raised to power 3, 2 raised to power 3. Okay? All right. Do you understand that? Good. Now, if you check, both the right hand side and left hand side have the same power. Okay? You see, they have the same power. Okay? Now, with that, I can equate the indices. I can equate the indices. If I equate the indices, automatically what is the same will go away. This 3 will go away, and I have my common ratio to be what? 3 over 2, which is the same thing as 1 number 1 over 2. Anyway, you want to put it. Okay? Now, I'm done with the first thing. I'm asked to find the second thing. I'm asked to find the first term. Okay? Now, you can see that we have 2 equations. What you just need to do is substitute common ratio, substitute R in equation You can use equation 1, you can use equation 2. Anyone that's convenient for you. I want to use equation 1. My equation 1 is 360. 360 equals to AR squared. This is my equation 1. Okay, what I just need to do is to substitute the value of my R. That shows that my 360 equals to A multiplied by, what is my R? My R is 3 over 2 squared. 3 over 2 squared is the same thing as A multiplied by 9 over 4. And 9 over 4 is the same. That shows that my A, my first term will be equals to 360 multiplied by 4 divided by 9. Somebody is saying, how do you get this? Okay? In simple terms, from this place, this is the same thing as 360 equals to A times 9 is 9A. Divide 9A divided by 4. Okay, if you cross multiply or you multiply both sides by 4, if you multiply this side by 4, you multiply this other side by 4. This 4 will cancel this 4. 4 times 360, which I have here. So I have 4 times 360 equals to 9A. The next step is to divide both sides by 9. If you divide this one by 9, the 9 will go away. You divide this one by 9. And you see 4 times 360 divided by 9. You see what I've gotten? Okay? That's what I've done. All right? That's it. So from this place now, 9. Okay, A. Okay, now my A will be equals to, this will be 160. Okay, that shows that my first term is equals to 160, and my common ratio is 3 over 2. You see that that's very simple. Okay, now if you have gotten this topic, if you see it very helpful, kindly like my video.